Alright, now we're going to look at sector area and sector length with radians. Again, remember, radians is just another way to measure angles. We can either measure them in degrees or radians. Doesn't make the angles any different. It's just a different way to talk about it. It's like Celsius and Fahrenheit when you're talking about temperature. So if we look at it, first thing we need are two of our equations. Our area equation for a sector is we're going to take our theta, which is the degree measure that we're looking for. We're going to divide it by 2, and then we're going to multiply it by the radius squared. That's for when we're finding our area. Our sector length, which we talk about by S, and remember our sector length is the length of this outside part of the sector, is we multiply our theta times the radius. So they're actually two more simple formulas. We've just got to understand when to use them and when not to use them. So if we look here and we scroll down a little bit, here we go, we can still see our formulas. Got everything there, fantastic. So if we've got a circle with a radius of 8 and a sector with a angle measuring pi over 2, find the area of the sector. Now just to give us a look of what this would look like. So we're going to have a sector here, and pi over 2, just to relate it to degrees so we know what we're talking about, pi over 2 is going to be a 90-degree angle. So we're talking about this sector here, and it's got a radius of 8. So what we're going to do, and we'll call that inches, so we'll say 8 inches. First thing we're going to do is find the area of the sector. So to find the area of the sector, we've got to take our angle, divide it by 2, and then multiply it by our radius squared. Our angle is pi over 2, and we'll divide that by 2, and then we'll multiply it by our radius squared. Our radius was 8, so we'll do 8 squared. If I look here, pi over 2 is going to become pi over 4. 8 squared is going to be 64. So if we look at that, we can simplify that. If we do 64 divided by 4, we know that's going to give us 16. So I could say my answer is going to be equal to 16 pi. Since it is area, I can call it inches squared. If you want to do the calculations, 16 times pi is going to give us approximately 50.27 inches squared. So that's how I find my area. I use my formula, I plug in what I know, and then I can evaluate it. Now the sector length, or the arc length as it's also called, if we get rid of our work here, we can find by using our sector length formula. Our sector length formula is we take our angle and we multiply by the radius. So my sector length, remember my angle is pi over 2, and my radius is 8, so I can multiply these together. 8 divided by 2 is 4, so I could say that this is going to be equal to 4 pi. Remember we were calling it inches. This one is just a linear measurement, so it'll be 4 pi inches. If you want that worked out, it'll be approximately 12.57 linear inches. So this line from here all the way to here would be approximately 12.57 inches. So you can see when we're working with these, they're not too hard to work with. Just have to know what the formulas are, and we have to be able to solve for them. The other thing we can do is we can use this to help to solve for some of our angles or for some of our radius. In this certain situation, we have a sector that has an area of 12 pi. It's got a radius equal to 9, and it's asking for the length of the arc. Obviously, if we look here, my sector or my arc length is going to be equal to my angle times my radius. You can see in this problem I don't have an angle, so I have to solve for my angle, which is why they gave us this area part. So if we think back, our area was equal to pi divided by 2 times our radius squared. Now I can solve for this to figure out what my theta is going to be. Let's plug in what I know. I know my area is 12 pi. I don't know my theta, but I do know my radius is 9. So I have 9 squared here. So I've got 12 pi is going to be equal to theta over 2 times 81. To get rid of that 81, I can divide both sides by 81. Divided by 81. So those are going to cancel out. And then I can also multiply by 2 and multiply by 2. So if I look at this, it's kind of ugly looking, but it's solved. I've got theta is all alone over here, and it's going to be equal to 12. Oops, I'm sorry. That's supposed to be a 24, because remember we did 12 times 2, which is 24, times pi divided by 81. And now if you work that out, and really actually, since this is radians, we don't have to work it out. We can convert it over to degrees if we wanted to, but since this is radians, we don't even have to worry about that. So if I get rid of my work here, and now I know what that angle measure is, I can plug it in, and I can solve for the length, or my sector length. So I can say that it's equal to my angle times my radius. My angle is equal to 24 pi over 81. My radius is equal to a 9. My 9 and my 81, this is going to cancel out and be a 1. This is going to factor down and be a 9. So I could say my sector length is going to be equal to 24 pi over 9. Or if I work it out and I do 24 times pi divided by 9, I'm going to get a sector length of 8.38. And since this calls it units and units, I know it's a linear measurement, I'm also just going to call it units. So we can use those formulas to solve for really any missing variables that we may come across.